Now let us look at question 19. Question 19 is testing on 3D. Not basically 3D, but it's testing on a surface area and volume of shapes, that is 3D shapes. Now you have been given a figure which is a pyramid VABCD. The base, which is ABCD of the pyramid, is 8 by 8. Then the length of the slant edges, this length of the slant edges, they are equal. It is 10 centimeters, all of them. Then from here, you are supposed to calculate the vertical height of the pyramid correct to 2 decimal places. Okay, the vertical height of the pyramid correct to 2 decimal places. So basically, if you connect point A all the way to point C, then drop a height from V towards the diagonal AC, this height is what the examiner is looking for. Now, we have the slant, which is 10. We can use AB and BC to look for AC using Pythagoras theorem. Then from here, get half of it, then you can look for this height. So basically, we first of all going to look for the distance AC. Now, for us to find the distance AC using Pythagoras theorem, we are going to take the square root of AB plus BC. So that is 8 squared plus 8 squared. And this one means it is the square root of 128, because it is 64 plus 64, which gives us 128. Now, if you go ahead finding AC, then you can look for the half of this. So half of this, that is A up to the, we can refer to it as letter P, which is that point P. So for us to find A to P, you're going to take half of AC. So it is the square root of 128 divided by 2, half of it, centimeters. Then we look for this point PV. Look for this point PV. So for us to look for the point PV, I want us to see this particular figure. This is the point P. This is the point V. This is the height they are looking for. Then this one is the point A. Now from A to V, this one is 10 centimeters. Then from A to P, we have said it is the root of 128 divided by 2. The root of 128 divided by 2. Now, still you are going to use Pythagoras theorem, and you find that height in this particular place is actually going to be, using Pythagoras theorem, actually going to be AV squared. So it is 10 squared. From it, you subtract the AP squared. So it is the root of 128 over 2, all of it squared. Now, when you carry out this one, the answer is going to be 8.25 centimeters. That is correct to 2 decimal places. So the vertical height of the pyramid is 8.25 centimeters. Next, it requires the surface area of the pyramid. A surface area of the pyramid. Now, this pyramid of ours, it has slant faces that are equal, slant sides that are equal, then it has the base. So we are going first of all to look for the area of the base. We're going to look for the area of the base. Now the base is basically a square, so it's going to be 8 times 8, and this one gives us 64 square centimeters. Then we look for the area of the slants. Now our slants are triangular, our slants here are triangular. Now, since we don't have the direct height of the slants, we can use the Heron's formula. Heron's formula says that area equals to square root of s into bracket s minus a into bracket s minus b, then s minus c. All of it is under root, where s equals to a plus b plus c divided by 2. Now, in this case, this side is a, this side is b, this side is c. Now, if we use the Heron's formula to calculate the slants, it's going to be square root 14. That means you take 10 plus 10 plus 8, that is 28. Half of 28 is 14, into bracket 14 minus 8, 14 minus 10, 14 minus 10. The square root of this one, you find out that it is going to be 8 into bracket the root of 21. Then, since there are 4 slant sides, you're going to multiply it by 4. And what do we get? If we insert this one directly into our calculator, that is 8 root of 21, then you multiply it by 4. You are going to end up with 146.64 square centimeters. So the total surface area of the pyramid is going to be area of the base, which is 64, plus the slant faces, which are 146.64. So a quick addition of this one, it is going to give us a total of 210.64 square centimeters, and that is going to be the total surface area of the pyramid. Next is looking for the volume of the pyramid, and we know that volume of a pyramid equals to a third multiplied by base area times height. Now this one is going to be a third. The base area is going to be 8 times 8 multiplied by height. Height, we found that is going to be 8.25, so you multiply it by 8.25, and this one is going to give us, so we insert them directly into our calculator, which is going to be 8 times 8 times 8.25, then this one you divide it by 3, and this one is going to give us exactly 176 cubic centimeters, and that is the volume of that pyramid. And that is how you're supposed to answer question 19 on the volume of a pyramid.